Alright, ladies and gentlemen, so what I'm going to do is I'm recording today because the internet has been going on and off all morning long. So what I'm going to do is I'm going to restart this lecture from scratch. Bear with me for a second so I can swap pages. Okay. Now, this section is section 10.3, and we're dealing with the parabola. Alright, and so in the parabola, if you recall, you have learned that the general equation is y equals ax squared plus bx plus c. The general function also can be written as y equals a, where this is x minus h squared plus k. Now, what I want to bring to your attention is that when we draw a parabola, obviously a parabola, we have two shapes. We either have where a is positive, so that means that a is greater than 0, and our parabola faces up. The second scenario for our parabola could be if a is negative, in which case a is less than 0, and in this case a is down. Alright. So, in each parabola, if you notice, there is an actual value that is considered the vertex. So in either one of these cases, we're looking at x equal to negative b over 2a. Now, having said that, what you want to consider is that this negative b over 2a is what we refer to as an axis of symmetry, right? And that's what this is. This is the x value for the axis of symmetry. In other words, it's splitting the parabola exactly in half. So this also has an axis of symmetry, right? Now, the other thing to consider here is that the vertex, so if I were to say that this is the vertex, and I'm looking at the x value. Well, this is the x value of the vertex, and then the y you can obtain by substituting x into the equation. Alright, so let me give you a couple of other formulas that you're going to need for this section. The other formula that we use for these parabolas, if you have a parabola that is, your standard form, where you have y squared equals 4px, and in this case that kind of shape would actually be a parabola that would be extending in this direction, alright, as opposed to a parabola where I have, in the case x squared equals 4py, and in that case that parabola shape would have a tendency to fall this way, or possibly down if it's negative. Alright, and so that is something to consider, and I want to show you an example before I even continue. Okay, having said this, we are going to talk about a couple of other concepts, but these are the basics that you need right now to start example 1. So let's start example 1. Alright, in example 1, the question stem says find the focus and directrix of the parabola given by y squared equals 12x, and then graph. So that's the question that they're giving us. So when they give us this question, I want to bring you back to the equation that I gave you earlier, where y squared is equal to 4px. So you can see clearly that the p-value would have to be 3. In essence, you're going to solve for 12, so we would say in this case, since x is already present, we know that for p, this part has to equal 12, so p has to equal 3. So with that said, we know that the focus, which is part of the question, tells us that this is going to be a p0, and therefore this is 3, 0, and that's the focus of our parabola. Now to find the directrix, we have x equals negative p. So in our example, x equals negative 3. So as I'm looking at my diagram, in other words, here as well, one other step that I need to take before I even bother drawing is this number here, which I'm going to use here. So 12 times 3, well, that's 36. So if y squared is equal to this, then y is equal to plus or minus 6. And that's the other y points that I'm going to need. So very simply stated, here's our parabola in our example. It's a 0, 0. I know that one of the major points that I need is the x is 3, which is my focus right here. Alright, and so I'm going to erase it for a moment. The other 2 points that I'm going to need are these. So these 2 points are going to render as 3, 6 and 3, negative 6. They're going to help me draw my parabola. So if I match this up, this should be somewhere about here. And this should be somewhere about here. So I know that my parabola definitely goes through that point at somewhere. Some instance, and then it goes through here. Okay? That's the foci. I'm going to go back 3 units, 1, 2, 3, and now my directrix is back here. This is my directrix, where x is equal to negative 3. Alright, so that's example 1. Let me do example 2 with you next. Alright, if you give me a second, let me get into example 2. Now, example 2 deals with a concept called the lattice rectum. Okay, in this case, the lattice rectum has to pass through the focus, so keep that in mind. It passes through the focus. And is parallel to its directrix. Now, if you look at this carefully, you have y squared is equal to 4px, where the absolute value for p is what we're going to use. This is the definition or the formulation you're going to need for the lattice rectum. Alright? So, in example 2, they work you through this extra step. And so here's example 2, where they are asking you to find the focus and the directrix of the parabola given by where we have x squared is equal to negative 8y. And then they want you to graph. So then they say then graph. So if we begin with this, we know that we have the formula x squared equals negative 8y. So we know that x squared is equal to 4py, and by default we know that 4p has to equal negative 8. For that to be true, then we know that in this case p is equal to negative 2. Alright, so our focus for this example is 0 comma p or 0 comma negative 2. The directrix, if you recall, becomes y equals negative p, which then means that this becomes y equals minus negative 2. Therefore, that directrix is y equals 2. Now, the latus rectum. Is the absolute value of 4 times p. In this case, it's the absolute value of negative 8, which is 8. So now we know with all of this information a few things. We know that the focus is 0, negative 2. The endpoints of the latus rectum are negative 4, negative 2, and 4, negative 2. And so if we were to sketch this, I'll bring this up this way. This should help us. Okay, and since it's a negative, obviously it's going down. So here's our vertex. We're going to go down 2 units. This point is our focus right here. And we know that that is 0, negative 2, right? Because we calculated it. Alright, we also know that we have endpoints. Since this has to be a distance of 8, we know that we have to go out 1, 2, 3, 4 to the negative 4, 1, 2, 3, 4 to the positive 4, a total distance of 8 units. Right, and that comes from that latus rectum. So we end up having a diagonal point, or excuse me, a horizontal line drawn this way. This gives us negative 4, negative 2, and this gives us the other endpoint for negative 2. Right. We also know that our directrix is here at positive 2. So let's erase that for clarity. Right, so I'm going to go up 2 points on the y, and I know that I have the directrix coming across this way. Okay, and then now just draw your parabola. We know that it's going to go through this point here, and we know it's going to go through this point here. Okay, once again, we knew that we had to draw it down because notice that its x squared is equal to negative 8y. Alright, so that's that example. Example 3 is very similar. Here, the only change is that they're going to actually give you some numbers. They're going to say to you, find the standard form of the equation of a parabola with focus (5, 0) and directrix where x is equal to -5. They actually give you the picture. Here's what they do. They give you basically, here's your XY axis, and they tell you the focus is sitting here at 1, 2, 3, 4, and 5. So at 5, 0, that's your focus. They tell you your directrix is sitting here at -5, so 1, 2, 3, 4, and 5. Here's your directrix. Yeah, I had to record because it broke down and it wouldn't. Okay, and then because we're given this information, we're going to use the formula where y squared is equal to 4px. And if this is my focus, then I have y squared is equal to 4 times 5x. So my equation is actually y squared is equal to 20x. Alright, and it's that simple. So that's the standard form for this equation. And yeah, they give you the drawing as well. They go out this way and this way. They don't give you the lattice rectum, but that you can solve for. Obviously, that's the absolute value. So we know we need to go 10 units in either direction. And so our lattice rectum should go through here and here. They don't really get into the lattice rectum in this example for some reason, but just remember, it's the absolute value. If you recall back to the notes, it's the absolute value of 4p. So since our 4p is 20, absolute value of 20 is 20. And so that means that I'm going to go 10 units out this way and 10 units out this way, right? And so you do the math. I mean, we're at the origin here, so this point here would have to be basically 5, 10, and this point here would be 5, -10. Again, they don't ask you for it, but it's nice to know, right? Okay. Now, example 4 is a little different. Example 4 says, given the parabola with HK. So we're no longer at the origin. So they want you to find the vertex, the foci, directrix, and then graph. Alright, and so if I have x minus 3 squared is equal to 8 times y plus 1. Alright, so what I need to start with is, well, first of all, h is equal to 3 according to this, and k is equal to -1. So that's the vertex. So we have 3, -1. Okay, in our example, the 8 is equal to the 4p portion of the equation, so therefore p has to be equal to 2. And that's just looking at the equation in a simplified version. So our directrix, however, so if I'm looking at the directrix, then k minus p is my answer, or value for the directrix. So in this case, y is equal to negative 1 minus 2, which is going to give me negative 3. Because remember, it is shifted 1 unit. And remember that this is comparable to x squared equals 4py. Okay, except now we have a shift in the center. What else do we need? We need the latus rectum. Latus rectum for this would be equivalent to the absolute value of 4p. And so therefore absolute value of 8, which is 8. Alright, and so that helps us find some major information. So once again, we know the focus. So 4 units to the right of the focus is the point 31. The endpoints of the latus rectum are, I'm just going to put LR for latus rectum, just know that that's that. So this will be negative 1, 1, and the other endpoint has to be 7, 1. And so now we can draw our figure. So drawing the figure, you have to remember, draw an XY coordinate. So we're at 1, 2, 3, go down 1. And that should be our vertex. Three, negative 1. So this is our vertex. Again, at 7, 1. So 7, 1, this would be my endpoint to the latus rectum. And at negative 1, 1, this would be the other endpoint. Notice that if I were to count units, this is 1, 2, 3, 4, 5, 6, 7, 8 units. You get that from that. Okay? Our directrix is at negative 3. So let's see, this is the directrix here. Okay, and we draw our picture. One like this, one like this. The focus is at 3, positive 1, so this is the center value here for the focus. And there's our latus rectum. Alright. So that is the key to graphing that. Alright, let's go down to example 5. In example 5, what they're going to do is they're going to give you the same question stem. So find the vertex, the focus, the directrix, of the parabola, given by, so if I have y squared plus 2y plus 12x minus 23 equal to 0, I want to graph this by combining all like terms on one side. So I'm going to keep this on this side, and I'm going to move all of this that's strange to the y on the opposite side. So in doing so, this equation becomes y squared plus 2y is equal to negative 12x plus 23. And now what I'm going to do here is complete the square. In doing so, I'm going to end up with y squared plus 2y plus 1 is equal to negative 12x plus 23 plus 1. This plus 1 was added here. I have to add it here. Okay? So now this collapses to where I have y plus 1 squared is equal to negative 12x plus 24. To express this in the correct manner, I'm going to actually take out the 12, negative 12, and I'm going to now simplify this to x minus 2, and so this is equal to the y plus 1 squared. So notice how this resembles the y squared equals the 4px equation. Alright, and so next step is, I want you to understand that this is the equivalent of y minus 1 squared. Alright, and so the 4p part of the formula, so 4p is equal to negative 12. According to this, I know that k is equal to negative 1. According to this, I know that h is equal to 2. Remember, the x associates with the h and the y associates with the k. Alright, and so we have a lot of information already. So we know that the center, since h is 2 and k is equal to negative 1, that, not the center, the vertex in our case, which mentally, doing some mental math is kind of like the center. And then here we have 4p, which is equal to negative 12, and therefore p is equal to negative 3. So that's our, that'll help us with the symmetry. We could tell the symmetry is, in this case, going to be horizontal. Okay, we also see that because p is negative 3, that we should have, the focus is 3 units to the left of the vertex. So we'll find the directrix as well using that information. So we'll start drawing. Okay, so at 5, we have our directrix. At 2 and negative 1, we have our vertex. Based on this information, we also have the latus rectum. If you recall, it's the absolute value of 4p. So in this case, the absolute value of 12, which is 12, which means I'm going to shift from that vertex, I'm going to shift equivalently 6 units down and 6 units up. So from here, 2, 3, 4, 5, 6, 7, so I'll be about here. So this point will be, well actually, this will not be here, this will be with the latus rectum, excuse me. We're here on this side. So this should be negative 1, negative 7. And on the opposite side, since we have this this value here centered at 1, negative 1, negative 1, from here, I'm going to shift up again another 6 units. So this will put me at 5. Alright, and so our parabola will go like this. And this is your latus rectum here. But remember, this is your focus, which is negative 1, negative 1. So these are endpoints of the lattice rectum. So this endpoint, -1, 5, and -1, -7. So those are the endpoints of the lattice rectum. I'm just going to put LR, those two. Okay? And that's just an identifier. Okay, takes care of that example, and I think we're good. There is one application question, but it in essence will mirror exactly what we've just done. And for the sake of ending this video and not losing the recording, I'm going to stop right here. So let me pause the video.